Exercise 2I is about simultaneous equations using the method called substitution. So if you look at the equation y equals x minus 3 and the equation x minus 3y equals 1, each of those equations has lots and lots of answers. There are actually infinitely many answers. If x was 5, 5 minus 3 would give you 2. So 5 and 2 is a solution. If x was 7, 7 minus 3 is 4. Y would be 4, so 7 and 4 is a solution. And the same for this equation. There are infinitely many solutions, but there's only one solution that works for both of them. So that example I just gave, if x is 7, 7 minus 3 is 4. If I put this in over here, 7 minus 3 times 4, I do not get 1. So 7, 4 doesn't work for this one. It works here, not there. There's only one solution that works for both. So the first equation tells us that y is the same as x minus 3. So what we can do in the second equation is replace the y with x minus 3. So here's the second equation. I've written it again, but instead of y, I've put x minus 3. And then I can solve this. So we've got x minus, now remember when we expand brackets, we multiply over the rainbows. So 3 times x is 3x, and then negative 3 times negative 3 is plus 9 equals 1. Let's collect up our like terms. So x minus 3x gives us negative 2x plus 9 equals 1. Let's minus the 9 off each side. 1 off each side of the equal sign. So we've got negative 2x equals 1 minus 9 is negative 8. Divide by the negative 2. So x equals negative divided by negative is positive. 8 divided by 2 is 4. So x is equal to 4. Now, we also must find the y value. So we can do that by substituting x equals 4 back into either equation. We actually will substitute into both equations just to be on the safe side and make sure we're right. So if we put x equals 4 in here, we get y equals 4 minus 3, which equals 1. So y is equal to 1. So x equals 4, y equals 1. And we're going to check that in the second equation. So this is just our check. If we put these numbers into here, we should get 1. So let's try. So instead of x, we've got 4 minus 3 times 1. Remember that means 3 times 1. So 3 times 1 is 3, 4 minus 3, that does equal 1, so it is correct. So we know walking out of a test that we've got full marks on that question if that happens. Here's a second example. Solve 4x plus 3y equals 37 and x equals 2y plus 1. Simultaneously, we're going to solve them. So what we're going to do is we're going to substitute 2y plus 1 instead of x into this equation. So I'll just write that first equation again. Now I'm going to rewrite it, but instead of x, I'm going to put 2y plus 1. The plus 3y is still there, the 37. And it's really important to put that in brackets, and then we can expand the brackets. So 4 times 2y is 8y. 4 times positive 1 is plus 4, plus 3y equals 37. Let's collect our like terms. So we've got xy plus 3y, which is 11y. The plus 4 is still there. Now we need to minus the 4. So 11y equals, that's gone, 33. Divide by the 11. So y equals 3. Now I'll put that back into this second equation first. So x equals 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. And let's check in the first equation. So 4 times 7, x is 7, plus 3 times y was 3, equals. So 4 sevens are 28, plus 3 times 3 is 9. That does equal 37, so we are correct. And you can see there the questions to do from the exercise, just A, D, and G from each one.